Okay, so today we have activity 2.2, difference of squares of transformations. So we're going to look at some graphing we were doing in the past, and then we're going to apply the difference of squares that your lesson for the last 2 days was on to transformations. So the first side is just a kind of a little activity. So we've got slide, slippity, slip, slide, slippity, slide. I can't even say it. The coordinate plane shows a graph of the function x minus 1 squared. So if you remember our transformations, this plus 1 is inside the parentheses. It goes opposite, so it went right 1. Again, because A is 1, okay, H is 1, and then K is 0. So we go right 1, up 0, and then there's going to follow that 1, 3, 5 pattern going up and reflecting. So that is the graph that we talked about our transformations. This is the graph. It says describe the transformations applied to the basic function that produces this graph. So what it was a transformation, you can just write that in at that spot. Okay. So then we have Lindsay and Casey determine the zeros of the functions algebraically in different ways. So if we look at the graph, we can see the zero of the function. There's only one. The zero, remember, if we talked about, is the x-intercept. So the x-intercept equals 1, which means the zero of the function is 1. We also said the roots of the function would be 1. Okay, and then the solution, if we made this into an equation, would be 1. So remember we talked about depending on the presentation, what is what. So if we're talking about a function, then we call them the zeros. Okay, so Lindsay took the equation and she put a 0 in, because if we're looking for the zeros, we put a 0 in for the function. So she put the f of x as 0, and then she factored difference of squares, or well, actually, since it's squared, there's 2 factors, right? She factored it, and she set each factor equal to 0, and we got 1. The equation has a double root, x is 1. And the reason why it's double, see how there's 2 of them. Okay? And then when we graph a double root, it always, what we call this a bounce. It always bounces at that point. Casey, on the other hand, took the equation and she said it's squares and we take the square root of each side. When you take the square root, there's a principal root and there's 2 roots to any square root. If we take the square root of 4, it could be 2 or negative 2, right? The square root of 4 is either positive 2 or negative 2. So when we're solving, we have to put this plus minus, could be either. And then you split it. This is if it's positive case, then negative case. So she solved and got the same solution for both again. So the only solution is 1. Okay, so it says, how can you use Lindsay or Casey's work to write a solution to the function in terms of the distance from the axis of symmetry? So we go back up to our graph. The axis of symmetry is at x equals 1. So the distance from the axis of symmetry is 0. So when we're trying to find the distance, it goes 0 units in either direction. So if the answer is 1 and it doesn't move in either direction, then the only solution would be 1. So you can, the axis of symmetry, x equals 1, is the solution. The distance away is 0 units. That's why it's set equal to 0. Okay, so make sure you fill in number 1 if you didn't, and then this part I just did with you. So let's look. So these are going to be an I do, you do type of situation for this rest of this packet. So example 1, consider the function f of x equals x minus 1 squared minus 9. How can we find the zeros graphically? So let's go back over our transformation. The h value is 1. The k value is 9. Remember, the vertex is at hk, so we have 1, sorry, it's negative 9. 1, negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can draw your axis of symmetry in. And then because A is 1, we're going to follow our 1, 3, 5, and then you could go 7, 1, 2, 3, 4, 5, 6, 7 if you wanted to, and then reflect that over here and draw our parabola. So it says, how can we find our solutions graphically, or our zeros graphically? We're looking where it crosses the x-axis, so negative 2 and positive 4. Right, so those are the zeros we found graphically. So the zeros are x equals -2 and x equals 4. So now we're in this new lessons we've been learning, we're trying to get away from graphing and how can we do these things algebraically so we don't have to draw that graph. We don't have to get a coordinate plane, we don't have to draw a nice accurate graph and find this solution. So how can we find this using difference of squares? So we're trying to find the zeros. That means we want the value when the function is equal to 0. So we're going to put 0 in place of the function, x minus 1 squared minus 9. And if we think about difference of squares, we have two terms. We have this term here. I can color code this for you. We have this term here, the x minus 1 term. And then we have minus. So difference means a minus the 9. So we have difference of two terms. And so difference of squares, as we've been talking about in the last lesson, you take the square root of the first term, which would be x minus 1, and put it at the beginning of each. And then you take the square root of the second term, which would be 3, and we put it at the end of each. And then one gets a plus and one gets a minus. So this is what we've been talking about. Okay, and if we solve this, it's equal to 0. So we're going to put the x minus 1 plus 3 equals 0. The x minus 1 minus 3 equals 0. X plus 2 equals 0. X is -2. X minus 4 equals 0. X is 4. Notice how the solutions, or the zeros, are the same as if we graphed it. So instead of having to draw the graph again and count it out, which you might say, well, that was easier, but there are going to be cases in which you're not going to have coordinate grid paper to do this on. You can find the solutions graphically. Algebraically. And just so we can color code where these went, this was where we went with the orange, and the yellow square root of 9 is 3 and 3. Okay. So now you're going to follow that same process and do this example too. So do it graphically and then do it algebraically. So now let's look at example 3. This one I'm going to do. So consider this equation. So now instead of giving a function, we're given an equation. How could this equation be solved using difference of squares? So I'm going to rewrite it here just so we can work with it. There's my equation. I want to use difference of squares. So I have the square here. I have another term over here in order to solve using difference of squares. And I want this to become a really big habit. Anytime you're solving an equation where the degree is greater than 1, the degree is greater than 1, any degree on x is greater than 1, you should move all terms to the same side and set equal to 0. So that's just a habit you should get into. So like we're looking at this, we have a degree greater than 1. That means we need to move the 5 to the other side. So then we have x minus 1 squared minus 5 equals 0. Okay, so now we can find the solutions, which again are the zeros of the function. So this is what we've been talking about. The solutions are interchangeable with the zeros. So if we set it equal to 0, we are now finding the zeros are the solutions. And now this looks just like the problems we were working with. So we're going to make our two sets of parentheses. We're going to take the square root of the first part, and that's going to give me x minus 1. And put that at the beginning of both. We're going to take the square root of the second part. The square root of 5 cannot be simplified, so we're just going to leave it like that. One gets a plus, one gets a minus, we put equals 0. And now to simplify, I'm going to drop away my parentheses. X minus 1 minus root 5 equals 0. And I get x by itself. The 1 moves to the other side and becomes positive. The root 5 moves and becomes negative. So there's the first answer. And the same thing here. The 1 moves to the other side and becomes positive. The 5 moves and becomes positive as well. And my second answer. So now you're going to use that as a model and do the next two. Okay, when you get to number 5, you're going to notice these are in the opposite order. It doesn't change anything. Solve through till you get d by itself, following the same exact steps. Okay, so difference of squares, follow these steps. Make sure you get it equal to 0 first and then factor.